Hello everyone and welcome to this tutorial on mapping. In this tutorial we will look at how to use the robot that we did build in previous tutorials to map an environment. We will look at what mapping is exactly and how does it work. Then we will look at how to use multiple LiDARs while mapping an environment. And then we will build a launch file that would allow us to run the mapping package and map the world. Then we will save this map for later use. Finally, we will actually launch the simulation from the launch file that we just built and map a house environment. So first of all, what is mapping? Mapping is the process of taking raw sensor data from the LiDARs and using it to determine where obstacles are located around the robot. All those obstacles can be allocated in one map, which can be then saved and used in navigation process. This will allow the robot to have an idea about a part of the world that the robot will navigate, even if those obstacles or parts are beyond the sensor range. And it will use this data to plan a path from A to B. So, how does mapping work? The mapping algorithm that we will be using will read data from a laser scan topic, and it will calculate the position and orientation of the robot and compares this data and then works out the sensor reading from the world and add all the data together to create a map which will be saved in a YAML file. Before mapping an environment, I have went ahead and downloaded a package that is called IRA Laser Tool. In our case, we have two LiDAR sensors, and if you need to map an environment, we need to merge the data from both sensors and publish it on the same topic for the gmapping node to be able to read this data. So please go ahead, download this package and copy it to your source folder in Catkin Workspace. And let's take a look at the package. So if you go to Catkin Workspace, source, IRA, launch, we will be using the laser scan multi-merger. So let me open this one. I'll open it using Visual Studio. You can see that what we are going to be looking at in this file are the topics. So we will be publishing, so scan destination topic, we need to change that to scan. This is the default name that we'll be using. And then we will list what topics are we using. So if you remember from our previous tutorials, we had a URDF plugin. We did create this file, and if we go to the laser region, you can find the name of our topics. So we are publishing on scan 1 and on scan 2. So we will list those topics here, and the package will take care of merging all the data from both sensors and publishing it again on a topic called scan. So it's pretty straightforward, nothing complicated actually. Now that we have edited the launch file, we can go back to our Gazebo launch file, and let me show you what changes I do here. In order to add an environment for us to map, I did include a file called house.world. You can go ahead to our Git repository and download the files, store them in a folder called worlds, and then refer to the file in our launch file. We did not change any other nodes. The nodes are still the same from previous tutorials. So now let me launch the package and show you how it looks like. Or let's first compile it. right? Let me source setup.bash and Rust launch example and gazebo. So this is the map that we have, or the environment that I did include, and our robot is spawning here at 0, 0, 0. So we will be creating a map of this house. That's what we have. In order to start the mapping, we need to create a launch file that would launch the required nodes for us to map an environment. Taking a look at this mapping.launch, you can also find more information at gmapping in RosWiki, and you can find a description of each parameter that we have used over here. You can read about the parameters that are used in this launch file and what changing each parameters would result into. So I will open this in Visual Studio. This is our mapping file. It has 3 arguments that we are telling the node what is our base frame, which is base footprint, and which is our odometry topic, and then where to publish the data. It will be published on a topic called map. And then we are running a node of type slam gmapping, and the rest is straightforward. So if we open a new terminal, and before running the gmapping, let me launch the IRA laser tool. I guess I need to source and we need the multi-merger. So now if we give it a second here, and open, so you see subscribing to topics. There are 2 topics that the node did subscribe to. We can Rust topic list to check what topics we have. We have scan, scan1, and scan2. So we will source again, and launch our example URDF mapping file. Now that we have launched the file, we can move to RViz, and let me add by topic the map first of all, and I will add the scan topic data to visualize the laser data. You can see that the merged data is sorry. You can see the data from the laser topics visualized in RViz. So if this is in the same rotation now, almost. See the table legs and the walls. So now that the node is reading the laser data and the position, we can launch our twist keyboard, teleoptist keyboard, and we can start moving the robot around to create a map of this world. So if I will move the robot around and let me change the fixed frame to map. So I will be moving the robot around. I am actually looking at gazebo window, and you can see how the map is updating in RViz. Let me zoom out a bit. So each new place that we go to, the robot or the node will collect data from the sensors and add it to the map. And you can see that the area is becoming wide. Let's say this is an accessible area, and we can go ahead and navigate or map the whole house. So please go ahead and navigate to all rooms, and if data is not clear, you can give it a second pass to make it a higher quality map. And at the end, we will when we're done with mapping this house, we need to save the data. So I will just go to the other room, and I guess the idea here is it's pretty simple. You just need to navigate the house. When we're done, let's create or open a new terminal, navigate to Catkin, source example, and create a folder, call it maps. And here, to save the map, the mapping node needs to be running, and then we would run the mapping node is still running here. So we'll run run map server and then map saver -f and call it map. So run this command, and we will save our map in maps folder. Let's go take a look at it. So in maps, it had created two files, a YAML file and an image representation of our map that we will be using later in navigation tutorial. So that's it for mapping. It's pretty simple, and if you have one LiDAR, you don't have to use the IRA merge tools. So we need to know which topic we're publishing the LiDAR data on, and we need to create a mapping launch file to start the mapping process. And at the end, we have saved our map to be used later in the navigation tutorial. That's it for this tutorial, and I will see you in the next one.